Hello everyone again, and welcome to this particular video. And in here we're going to be looking at savings and moving from that into investments, and how these two actually relate all comes down to the mathematics on how you put money in a bank for X amount of years and that appreciates over time. So the bell work here is to actually the goal you have to be able to effectively determine simple interest and then apply simple interest to compound interest and then determine future value of an investment, and finally take advantage of long-term savings strategies. So since you have that taken care of, we're going to look at the key terms that we're going to cover in this particular video. So the key terms includes the term deposit, and this is followed by the present value and what it means for a principal to be added or to be started from a specific payment, and then this leads into simple interest that is included into the principal, and that leads to the final value after X amount of days or years or months depending on the interest rate, and this is finally included or combined when dealing with compound interest. So let's look at how these terminologies that we've actually talked about here will be placed on a mind map and how they connect to each other. So the term deposit, we know that to be the money that you actually put into a savings, and this is mainly looking at it in terms of either calling it the present value or it is noted as the principal, and this principal we know is put in a savings account in the bank, and this money that you put down will appreciate definitely over time, and this appreciation of your principal into the future value or the present value depending on the category is actually influenced by the interest that is actually added to your principal. And the interest comes in two ways. One is the simple interest, where that is a formula which is your principal multiplied by the rate and time. And speaking of that particular principal, we have the money, and this is included or is influenced by how many times that interest is added to the principal over X amount of years, and the annual rate usually depending on the bank actually changes, so you have to have a constant rate at a specific time period, and that actually will be instrumental in increasing your principal into your amount of present value, and the amount is determined by the sum of the principal and the interest, which is the product of the principal, the rate, and the time. So that is how your money appreciates over time. And the second method, which people actually see it as so much more beneficial, either in terms of savings or you're paying interest upon a loan, that is actually governed by compound interest, and this is actually noted as when your amount of present value is actually performing the same simple interest multiple times over time, and this is actually going to be influenced mainly by what we know to be the interest rate. How many times is the interest rate applied to the amount of present value? Is it either annually, semi-annually, quarterly, monthly, daily? And all these rate pay periods actually do influence how much money is actually gathered at the end of that particular term, and this actually leads to the future value, and the future value is where you're going to reap the fruits of your labor, and that is the formula for finding the future value dealing with compound interest. And you can use that in your calculator, and your money just appreciates over time. So looking at it, let's look at specifically the principal, and the principal actually dealing with simple interest is when you multiply the principal, which is how much money you put in as savings first, is multiplied by the rate at which the interest is actually going to be added, and then this is going to be multiplied by the time that money is actually staying in that particular account, and that leads to your simple interest, and that interest money is added to your principal to determine the amount of money that is currently present in your account after X amount of years. And this calculation is performed only once, so keep that in mind. However, look at it in terms of the compound interest. The compound interest in here actually focuses not only on multiplying the future value by, or to determine the future value, but most importantly how the principal is actually multiplied by this particular exponential function by using your calculator, and you will be able to determine what the future value is. So take note in here that the principal is actually the product, or P represented as P, R is represented as the interest rate, I represents the interest amount, which is pretty much the simple interest, time is represented as T, the compound interest to determine that is a future value, which is FV, and we have the N, which is an influencer in this particular interest, and it is number of times the rate is paid annually. So keep that in mind. So moving on to how compound interest is actually apart from the annual, we notice that there are different ways compound interests are included. Like we saw on our two previous slides, we know that a compound interest could be paid either daily, monthly, quarterly, semi-annually, and annually. So now we're going to determine how many times do you get paid, or will the interest be added into your principal if it is daily. Since we know that we have 365 days makes a year, which means in this case that for 1 year you are going to get paid how many times? 365 days. And once we have that taken care of, we have, how about if you pick the plan for monthly? It means that we have 12 months in a year, which means that in here we're going to have 12 that is going to be multiplied, or it will be done 12 times in a year. The other is for quarterly. We know that a quarter is 1/4, which means that we have 4 times that particular interest that is added to or included to your principal in a year. And how about semi-annually? We know that this is going to be twice in a year. And finally, for annual rate, is going to be done only once in a year. So it depends on the plan that you are going with. The higher the number, it means that the more times you will get paid that interest every single year. So that is one thing to keep in mind. So how can you apply your calculator to the compound and simple interest? All you have to do for simple interest is, we know that P times R times T is what you have to do. So what you multiply, once you multiply your principal by your rate, which is going to be the decimal form of the percentage, and your time, you're going to get your simple interest. And thereafter, if you look at the compound interest, it means that we need to find the N, and that N number is actually representing the annual compounding times, which means that it has to be, if it is compounded daily, it means that N will be 365 days. And if you want to find the big N, which is pretty much the power, which is N multiplied by T, we're going to get in this case 730. So in here, if you want to get your future value for that, you just got to put in those numbers into your calculator, follow the appropriate symbols and various functions, and you should get your answer in this particular case right here to be your future value to be $1.01 or 10 cents or 11 cents if you round up. So on the other side, if you want to find the amount for the simple interest, it means that you add your interest to your principal, and that will give you 101. What you see here, $1.10. What you notice here in this case is that we see that the compound interest actually way more than the simple interest plan, and there's also some things that actually influences why compound interest is way more beneficial than that of simple interest. And this comes down to what we know in terms of simple interest. Once we look at simple interest, the calculation is done once, which means that, for example, if you're given the principal of $100 and the rate is 2%, and we have the time period to be 2 years, in this case we are doing this calculation once, or you can just say that, okay, we are doing it 2 times, but it will be for just 1 year. So in this case, for our first step is we look at the principal, and the principal, which is represented by P. The next one is the interest rate, which is represented as R, and T is represented as the time. And in this case, once we put down our numbers for that first year, which means that $100, and the interest rate is going to be 0.02, and the time is going to be after 1 year, we're going to get the interest to be around $2. And if you do the same method for the second year, which is the same principal as the original, and we do that, we also get the same number, which is $2. In this case, it means that the total interest will be the addition of the year by year interest in dollars. Now let's look at the compound interest and see how this is different from the simple interest. What we see in here is that there is a key message in here, which is for the rate, it is $2 per year compounded. Don't forget that, annually. So the compounding period actually influences the compound interest being greater than the simple interest and way more beneficial than the simple interest. So how do we influence our compounding rate to the time? What we have to do is, since we know it is compounded annually, it means that you get paid once, which means in a year, which means that if it is in 2 years, we'll get paid how many times in 2 years? Twice in 2 years. So therefore, we're going to have 2 rows to take care of, and these 2 rows, since we know the principal, the rate, the time, and we want to find the interest, it means here that we have to multiply our first simple interest, which involves the principal, the rate, which is 0.02, and the time, which is after 1 year. We'll get the interest for that first simple interest to be multiplying all 3 together, and we get, in this case, $2. So if you add the $2 to your principal or present value, in this case we're going to get our future value, which is equal to $102. Now take note that once we head into the next pay period, which in this case is year 2, we are using the future value of the previous particular period as the new present value. So 102 will be the present value, and then we repeat the same simple interest, which is in this case 0.02, and that same year, which in this case now is 2 years in total, and then we have our interest, which is equal to the principal times the rate times the time, and in this case now it's actually increased by 4 cents. And in this case, once we add our present value and our interest for that second period, we actually get $104.04. So in this case, what we realize here is that if you look at the total interest for the simple interest, we actually have 2 plus 2, which is $4. However, if we look at the compound interest, it's actually more by 4 cents. So in total, in here, when we find the future value for the simple interest, if you add the principal to the total interest, we actually recognize that the principal is $100 plus the total interest, which is $4, and that gives us the $104. However, if we do that method for the compound interest, it means that the last cell of that particular table is pretty much the future value, which in this case is $104.04, which is remarkable right there. 4 cents way more than that of simple interest. And if you do this over more years and more compounding period, you will get way more money than what you actually started off with, compared to that of the simple interest, where you get less than where you started from. So looking at this, how about we perform the next, I would say, case scenario, which in this case involves looking at compounding periods, where you're going from something that is big to a much smaller compounding period. So in here, big means in this case you're going from annual, but you're going down to something that involves the way less period compounding, which in this case is semi-annually. So you're getting paid in this case 2 times in a year. So what we see here is that if the total time it takes for you to invest in that money, or invest that money, is 2 years, we get the total times that our interest is added to your bank account to be 2 times 2, which gives you in this case 4 times. So if you have 4 times, it means that you are going to have 4 rows, and once you have 4 rows in your table, then this means that you're going to perform the simple interest 4 times, starting from the present value to the future value, and the future value of the original becomes the current present value. So if you do that logic after setting your principal times rate and time, and we perform to determine the interest, the product of the principal, rate and time, and that gives you the future value when you add your interest to your principal to be $101, and then that future value becomes the current present value for the next roll. And once you do the same process, we actually get the interest to be $1.01. Add that to your principal, which gives you in this case $102.01. Now that is actually really good. And then you do the same method, we get the interest to be $1.02, and that gives you your future value to be $103.03. And then the final step, you do the last simple interest, with that future value becoming the current present value, and that actually goes on to give us our interest to be $1.03, which becomes in this case $104.06. Now we see the difference between the total interest compared to that of the compounded annually versus that of the semi-annually. We have a difference that is 2 cents more for the same semi-annually compared to that of the annual compounding rate. So as a result of that, it means that our future value for semi-annually is 2 cents more than that of the annual rate. So we see here that you actually make more money over time going from annual to semi-annually. So in this case, in conclusion, what we can gather here is that for a long-term saving strategy, one important thing here is that as you go from annually all the way to daily, you actually have an increase in that particular end value, which is actually influencing that more money that you actually get out of your savings account in there. So you're going to make more money, or there'll be an increase in your interest as n increases, which is going from annually to daily. And the other thing is to take note of your R, and the R is the rate. So if you increase the interest rate, automatically you're going to have a better future value or greater future value compared to where you actually started if you get a smaller R value. And the next and final one here is looking at the T, which is the time you actually set up your investment for. So it means here that the longer the time you actually put your money in that particular account, savings account or investment, it means the better or the greater the future value of your investment after X amount of years. So you need to take these three things into consideration when investing money. One, you want to have more compounding periods, which in this case is you want to go for daily rate compared to that of the annual. Next is you want to pick something that has a higher interest rate for your investment to reap great rewards. And finally, you want to leave that money for a longer period of time. So once we have this taken care of, we're going to look at various cases and examples from what you guys will be doing on your assignment. And this is one where you have to write the terms from column B and complete the sentence in column A. So using column B, you have to fill in the blanks in column A. And the first one here says that the original amount of money you invest or save has two names, which are what? So looking at column B, we know that yes, present value is where you're starting or how much you're investing at first, or you can actually call that the principal. So the principal is also the money you invest or borrow depending on what you're doing or you're saving. That is the initial money that you're putting into the bank account that you expect, or that investment for you to get future rewards down the road. Now the next question, which is 2, says the initial money that is deposited into an account for a specific time period is called what? So we know that this is a term deposit, and this is the initial money that is deposited into an account for a specific time period. That is what you should remember for sure. And the next for 3 is that what you earn on your initial money when you save or invest is called what? So based on this, we know that it is the interest that is added to your principal money or initial money or investment to your investment, and then at the end you actually get your future value, which is for number 4, where it says that the amount a savings money is worth after any future is called indeed the future value. So that's it for this particular question. And the next question here involves simple interest, and in here we're given the formula and we're asked to write this in words. So pretty much what this means here is that it is the interest, and this interest is equal to the product of the principal, which is represented as P, and R is represented as the rate interest. This is the product, don't forget that, and you're multiplying that by the time period, which is in years. So based on this formula, this question actually asks us to determine Thomas' actual money he gets back after he borrows $200 at 10% simple interest. Don't forget that is key. that will be paid back after 6 months. So take note that this is not up to 1 year, and we know that for 1 year it is 1. If it's less than 1, you have any value that is between 0 and 1. So if you look at what is borrowed, how much money, this in this case is $200, which in this case is the principal. And in this next part here, we have 10% simple interest, which in this case is the rate. The rate is actually 10%. If we change that into decimal, it becomes 0.1. And then next here is to find how long that particular interest is lasts for before it's added to the borrowed or principal money. In this case is 6 months, which is the time. So if you convert that to decimal, which is not up to 1 year, it means that it is 0.6 based on our calculation right here. No, 0.5, because in 6 months that is pretty much half a year, and the other 6 months is 1. So yes, 0.5 years. So to find the interest, it means that you have to multiply the principal by the rate and the time. And in this case here, we're multiplying $200 by 0.1 by 0.5, and your interest in this case is equal to $10. So in here, how much does he get back? Actually is a combination of the principal and the interest. So if you add those two numbers, which is $200 and $10, you will get $210 as the money that he will get back. So that is it for the simple interest. So how can you compare the simple interest and or differences between simple interest and compound interest? Based on our previous slides, we recognize that the simple interest is calculated only once, and that is it. And we know that the rate is multiplied by the time and multiplied by the principal in order for we to find the interest. However, the compound interest is calculated several times, and you earn interest on interest, which is the beauty of it in here. So that is it in here for simple versus compound. And in here we have another question which involves Silva actually investing $3,000 at the bank into a bond for 3 years, and the bond actually collected simple interest of 2%. And the question asks you how much was the bond worth, which is the future value at the end of the 4 years. So that should be your interest as your answer. But how can you determine that I to be your answer to be 180? So I'll give you a few minutes, try and use simple interest calculations and find the interest, and then once you've solved your answer, play the video again, and then you will see the solution. So the solution here actually shows us that we have the investment money, which is in this case the principal, to be 3,000, and then we have the years, which how that bond lasted for, which is in this case 3 years. So our time is 3 years, and then the next here is what is the rate, and the rate here is 2%, which in this case, if we convert it to decimal, it becomes 0.02. So once we have that, we need to take this into account. Simple interest, it doesn't say compound interest, which means we are doing this interest calculation once. So we're going to perform this particular calculation, P times R times T, and this is actually what the interest will give us when you multiply your $3,000 by 0.2 by 0 or by 3. So in this case, your interest will give you $180. And once we have that interest, our next question to ask yourself is, what is the future value after 3 years? I actually made a mistake there. I have a typo. It's supposed to be 3 years, not 4 years. So for the future value, the annual the amount is equal to the sum of the interest and the principal. In here we know the interest to be 180, and we know the principal, which how much the person put down first, to be 3,000. Therefore, in here, if you add that, your amount of future value will be equal to $3,180. So that is it in here for that particular bonds worth after that many years. And next here is how about this process is done through compound interest, and how are you going to determine how much money is made if this is compounded semi-annually. So let's look at this process here. We have maybe one part filled out, but that's not going to be the case on your worksheet, so you want to be able to deal with this properly. And we have a couple of tables to fill out, and in here we notice 3 years, which means that we want to deal with the compounding period. How many times is this particular rate or interest actually added to the principal? In this case, if you multiply 3 semi-annually, means you get paid twice a year. So it means that in 3 years you're going to get paid that interest 6 times. So it means you have 6 rows that you have to complete, and so your first year is actually 0.5. So after half a year you actually have to complete that, and then this is followed by after 1 year, and then after 1.5 years, and then after 2 years, after 2.5, and then after 3, the third year. So based on this here, the principal in this case is investment money, which is 3,000, and that is what you're going to think of in here. And the next one here is 2%, which is the interest. So once we have the interest rate to be 0.02 after converting, and we know that the time period is going to be every half year, it means that you have to populate everything down to the very last row. So we'll have all those repeated how many times? 6 times in here. But then the next part is to determine the present value, and the present value here for a start is going to be multiplied by the rate, and this is going to be multiplied by the time, and this will be equal to the interest, which is the present value, or principal times rate times time. So as a result, what is the present value after 0.5 or before 0.5? It is 3,000, and then once you multiply the rate by 0.02, and after 0.5, you actually have this interest, which is $3,000 added to your present value, which gives us the future value to be equal to 3,030, and that future value becomes the present value after year 1. And heading into year 1, you have that same rate and time, and once you multiply those, that gives you that interest, and that interest, once you add that to your present value, that gives you the future value after 1 year. And going into a year and a half, you actually have that money. The same thing, you multiply by the rate and time, and that gives you the interest, which in this case is increasing close to by 30 cents, and what we see is now $30.60, and thereafter you add the interest to your present value, and that gives you the future value, which is now $3,090.90, and that now becomes your present value for the next, which is heading into year 2. Once you perform the simple interest for that, you get your interest, which in this case is $30.90, and once you add that to the present value, that gives you that money, and that money becomes the new present value. Do the same simple interest after heading into year 2.5, you get the simple interest to be $31.21, and if you add that to your present value, that becomes your future value. And finally, after heading into the final year, which is year 3, we have the present value becoming now the interest after multiplying 0.02 by 0.5, and we get $31.53, and this gives us our final future value after 3 years to be $3,184.55. Therefore, in this case, what is the future value for the investment or of the investment? It is actually that money, or you actually do this in your calculator, which means that in this case our n becomes 2 and our t is 3, our r is 0.02, and our principal is 3,000, which means you punch that into your calculator, you either get that number or you just go to the last cell of your specific table, and that will actually be pretty much the same answer as what you got on your calculator. The only difference is just like 0.1 or just 1 cent. So that is it for the future value. But how about the interest? How will you determine the interest? There are multiple ways to go about it. Either you look at the column, which is the I column, and add everything, and once you add that value, you actually get your number to be $184.55. That will be your interest right away after 3 years. Or you you subtract your present value that you started, or your investment you started with, which is 3,000, from the future value after 3 years, which is 3,184.55. Therefore, this will give you the same number, which is that particular value, $184.55. So that is about it for this particular video, and this actually involves you being able to know the differences between simple interest, which is calculated only once. However, compound interest is done how many compounding period that particular interest is added to your principal. That is the big takeaway message in here for chapter 5. So please don't forget to hit the comment down below. Let me hear your thoughts, or send me an email, or set up a Google Meet. By that way, I'll be more than glad to help you out with this. All the same, stay smart and believe in yourselves.